Let's code. Let's have a look at the shopping basket program. Items equals 3. Price equals 4. Total underscore cost equals items multiplied by price. And then finally we print out and concatenate by joining the strings where we find out the total cost and output the total underscore cost variable. Just a very quick one. All variables, if there's two separate words, must have a character in the middle, and that's why I put an underscore in the middle to join those two words together as one word, because Python has rules that are just like that. Okay, let's run the program. So my total cost is 12, where I've taken 3 multiplied by 4, stored it in total cost, and then outputted the total cost. Why don't we have a look at changing some of the values in the program and predict what's going to happen. Okay, so if I take the number of items and I change the number of items to 7, we've got 7 items, and the price, this time, the price is going to change from an integer to a floating point value, which is called a float. So I'm going to change each one to £3.50, and we'll see what's outputted this time. Let's predict it first before I click on the little play button down here. Okay, let's click on play. Okay, so my total cost now is £24.50, and you noticed how it's outputted a floating point data type rather than a whole number integer. Let's change this again. So £3.50, we'll change it to £3.45. And what we'll do is we'll change the output to the total cost is, and we'll put a pound sign in there instead of putting the colon. It's just going to make it a little bit more realistic. And what I'm going to do as well, I'm just going to add on a print statement at the top. Welcome to Tesco. Let's click play, see what's going to happen. Okay, so it's starting to look a little bit more realistic. Welcome to Tesco. The total cost is £24.15. This is the type of system they have in store. So we're looking at more realistic programs now. What happens if I take this line of code, cut it out and paste it down here? Let's predict what's going to happen. I get a name error, price is not defined on line number 5. Line 5 is this one where it's trying to look for price, but price doesn't exist until line 6. If I cut this back out again, we can see that this runs like it did before, where it's £24.50. Let's code together. Okay, let's have a look at the main program, the canteen budget. So, I have a budget of £6. A drink is £2. And a snack is £3. I'm going to calculate the amount that I spend, which is the drink, add the snack, and then the remaining amount left, which equals the budget, take away how much I've spent. And let's output the remaining value, remaining money left over, which is remaining. Let's run the code. My remaining money is £1, where I've got 6 to start with. I've spent £2 on a drink and £3 on a snack. 3 plus 2 is 5. Take away 6 is £1 remaining. Let's see what happens when I change these values first of all. So I'm going to change my budget from £6 to £5. Let's try and predict what's going to happen. So we've currently got £0 remaining. I can't buy any more food for the day. Let's see what happens though. If I've only got a budget of £3, let's try and predict what's going to happen. Okay, I've got negative £2. I owe the canteen £2. Let's see what happens when I make snack appear down on line number 7. So it's out of order. Let's see what happens. Okay, I get a name error. Name snack is not defined on line 5. This is what's called a syntax error. Python doesn't understand what's happening because the lines of code are out of order. What's happened is snack appears above snack being initiated and assigned. So Python doesn't understand the order of the code. So if I cut this back out and paste it back in here, Python should understand what's happening, but I still owe the canteen £2. Let's change this slightly just to make it a little bit more realistic. Let's do a print statement. Welcome to the canteen, and you can code with me. And for the remaining money, I'm going to, instead of putting a colon, I'm just going to put a pound sign so it appears like the money is real money. And I'm going to change this back to £6 so I don't owe the canteen money. Let's see what happens when I play it. So welcome to the canteen with the remaining money left over of £1. Let's code. And this is the main program, a simple login screen. So we have our username equals input. And we're prompted in a string for username. And then password equals input. And then prompted for a password. And then I get a nice straightforward output. Welcome. Username. And bracket. Let's run the program and see what happens. Let's enter my username. GCSE 1. My password. Computer science. It's not spelled correctly. And you see how it outputs the username as GCSE 1 and my password is stored in a variable. This is a very straightforward login system. I could add to this by using selection statements, and that will come later on when we create more complex programs. Let's code. Okay, the cinema ticket calculator. So we take the adult tickets equals integer or whole number, and we use the input and number of adult tickets. And we always have two brackets on the end. Because we've opened two, we always close two. And we're going to do the same for child tickets. Child underscore tickets equals int input number of child tickets, colon, space, and 2 brackets at the end. We need to look at the price of adult tickets, which equals £8.50, and we'll look at changing these later and see what happens to the program. Price of the child tickets, we all make mistakes. Price child equals £4.50, and that's a float value. And then we are going to do some calculations. So we're going to take the adult total, which equals adult tickets multiplied by price underscore adult. And then we take the child total variable and we look at child tickets and we multiply this by price of the child. We create a total by just adding these together. Total equals adult total, add child total, and then we're going to do an output where we go total to pay and then a comma, and we output the total. Let's see what happens when we run it. Okay, number of adult tickets. Let's say we want 2 adults and 2 children, your typical family. Oh, we've got an error. Adults tickets. Okay, that's quite a good thing. Because this program is a little bit more complex, it's probably a good thing that I've made a mistake here. So we've got adults tickets, and up here I've got adult tickets, so they don't match. And like I said, we all make mistakes, but it's absolutely fine to make mistakes because we always learn from them. So let's run it again and see what happens. Hopefully I've made no more mistakes. Number of adult tickets 2, number of child tickets 2. And my total to pay is £26 or 26.0. It doesn't quite look like a monetary value. So I'm going to go in and I'm going to change a couple of the values so they are slightly different. So here I'm going to change this to £8.75 because I think adults pay a little bit more than that. And I'm going to change a child ticket to £5.25. And actually I'm going to change this to £5.50. And I'm going to change the output to thank you, total to pay for your tickets is, and then rather than a colon like I've done in previous programs, I'm just going to put a pound sign. And I'm also going to do a welcome to print output, welcome to the cinema, just to make it a little bit more realistic. And you can code with me and do this too. Okay, let's see what happens when I run it. Okay, so I've changed a few values. We should get a more accurate program by doing this. So it says welcome to the cinema, which is a nice little welcome. Number of adult tickets is 2. And you remember before it said £26. Number of child tickets is 2. Thank you. The total to pay for your tickets is £28.5 or £28.50. Okay, so I'm going to go in again. I'm just going to remove this, X this out. I'm just going to pop this down here just to see what I get. I should get an error coming back. So the price, it's going to run through from top to bottom like it normally does. I'm going to say 2 and 2 again. And you see here I've got a name error. The price of the child So price of the adult is there, but price of child isn't there. And when it's trying to use it in its calculation, the price of the child here, it can't find the actual price because the price is further down in the sequence of the program. So let's remove this, cut it out and paste it back in. And let's see how many, if we've got 2 adults, and let's say we've got 7 children. Must be a birthday party. And my total to pay is £56. Okay, let's code. Age equals int input, enter age, 2 brackets on the end, because we've opened 2 brackets, we close 2. Has underscore ticket equals input. We're expecting a string on this one. Do you have a ticket? And we need to prompt them to say yes or no. So we'll just do yes, no, and then we also need to close the quote, close the bracket. We don't need 2 brackets on the end of this one because this one's going to be a string. And we'll start writing our statement. So our selection statement says if age is greater than or equal to 12, and this is a key word we haven't really come across before, but the word and means you can join 2 conditions together in the same sentence, and if they're both true, it's going to print out entry allowed. And has underscore ticket equals, double equals means directly equal to, and if has ticket is directly equal to yes, the word yes, colon, never forget the colon, because it creates the little indentation and we can print out entry allowed. So when we press enter now, it's still indented, so what we need to do is just go back twice, because our else needs to line up with our if, and else will always have a colon on the end as well. So when we print out entry denied with quotations around it because it's a string, we can run the program and see if it works. So if I test all these conditions just to see if the program selection works, I'm going to enter, first of all, I'm going to enter 13 for the age to test to see if the age works, and I'm going to say yes for a ticket to see if it outputs entry allowed, and it does. Perfect. I'm going to press run again, and this time I'm going to enter age as 11. So this condition is false now, but I've got a ticket, and see if it outputs entry allowed or denied. You predict. Entry denied. So the first condition is false, but the second condition is true. So this word and really works in this scenario, and it defaults out of this because it ends up as false and prints entry denied. Let's try it again. If I enter age 11 and ticket as no, it should be entry denied. And finally, let's run it one more time and do 14 and a ticket as yes, and entries allowed. We can make this a little bit more realistic again by printing out welcome to the cinema. We could pop an emoji in here as well if we wanted. Let's pop an emoji in. An emoji is classed as text. It's part of Unicode. Entry allowed. I'm going to pop a little emoji in here as well, just as a little celebration, so you can allowed into the cinema. And I'm going to play around with the age. So instead of a 12, I'm going to say a 15 and see what happens. So welcome to the cinema. It's a little bit more realistic. Enter age. Let's say 16. And has a ticket. Let's say yes. And okay. And entry's allowed. With a little celebration after it. Make sure you've entered all the programs so far into Create with Code. And then we can move on to doing an exam style question. Okay, school reward system. Code with me. So we have an input statement for attendance as a number. Attendance as a percentage. The percentage sign is shift and then 5. Colon. But that's inside our string and double bracket. Then we have behavior. And again, this is a number. Behavior score. And 2 brackets. And then we start our selection statement on line number 4. If attendance is greater than or equal to 95 and behavior is greater than or equal to 4. So I've got 2 conditions there. They both have to be true for this print for a gold reward. Then I'm going to start my ELIF statement. ELIF attendance is greater than or equal to 90 and behavior is greater than or equal to 3, colon. This will print out, which is my silver reward. And then if all these conditions are false, my else is going to kick in, and my else statement says no reward. Unlucky. What I want to do is run the program. Let's have a look at our attendance. So if my attendance is 96 and my behavior score is 5, I should get a gold reward. Correct. Let's run it again. If my attendance is 92 and my behavior score is 7, I should get a silver. Oh, I've run it again. If my attendance is 92 and my behavior score is 7, I should get a silver. I do, I get a silver reward. Let's run it again. If my attendance is 89 and my behavior is 6, I should get a no reward. No reward, correct. Okay, so I've tested most conditions here. What I want to show you is how changing the order of if, elif, else statements can result in an error, a logic error that is, not a syntax error. So if I cut this out, and I'd like you to do this with me as well, and I plonk this here, and I change this to my if, and I change this to my elif, this is why logic and the correct order matter. So what will happen here, I'm predicting, is that the program will run correctly, first of all. So if I enter my attendance, as 97% and my behavior score is 8, you predict what's going to happen here. Give me 5 seconds. Okay, let's run the code and see what happens. So here I get a silver reward. So my silver reward has been awarded even though I've got an attendance of 97 and behaviour score of 8. This is because my if and my ELIF are in the wrong order. What you need to make sure you do is always have the larger numbers in the if statement as the default, and then you follow on with the slightly smaller numbers as you go down. So I'm going to change this back now. I Control Z in it. Let's code. Okay, let's have a look at the school trip program. So we have our age, which is an integer. And we want someone to input it. Enter age, colon, double brackets. There we go. We all make mistakes. Permission is going to be a string, so we don't need to enter any data type for this. Input, permission slip, yes, no, and one bracket on the end. Let's pop a bracket in there as well. Let's make it look correct. On line number 4, we've got if age is greater than or equal to 13. So you must have to be 13 to go on this trip. And then we're nesting this one. If permission, it does get a little bit more complex, this. You've just got to make sure you do the colons. Equals equals. Yes, we'll do yes in lowercase. And now we're going to print out trip approved. Now this is where it gets a little bit more complex because we've got to go back. So the inner if lines up with this else. So else print, and this is where we get permission missing. And then once we've got permission missing, we're going to have to press enter and then go right back to the edge and do the else for the first if, which is you're too young for the trip. So I'm going to print too young for the trip. It's really important on these that you don't rush the code because the indentation is quite a little bit more complex than we're used to. So don't rush it, get the indentation correct. I'll give you a clue. So if I go take this one back, this is just 2 spaces in on Create with Code, and this one is 4 spaces in. So the inside ifs are 2 spaces in, the inside prints are 4 spaces in. And you'll see that it marries up nicely when you do each colon correctly. Okay, let's see what happens when we run the code. So if I enter my age, I want to test this on multiple. I'm going to do the exact age that you're supposed to be, which is 13, and permission slip. I'll just put yes. Trip approved. Perfect. So that works. Let's try it again. Let's enter a slightly younger age, 12. Permission slip. Yes. Too young for the trip. So it seems to be working so far. Enter age 15. Permission slip. No. Should say permission missing. Perfect. Okay, so what I'm going to do, I'm just going to test this out. I'm going to remove int from this top line. And I just want to see what happens. Let's have a look. And when I press play. Okay. So I've got a bad input on line 1. It knows I've made some kind of mistake. Let's take this bracket off as well and run it again. And just see if it runs. Enter age, because I want to see if it can recognize if it's greater than or equal to 13. 15. Permission. Yes. Trip approved. Okay. Let's try and do it if it's 11. And permission. Yes. trip approved. So Python does recognize that this here, 13, is an integer. So the input doesn't necessarily need to be an integer, but it is good practice to put this as an integer. What I'm going to do as well, I'm just going to remove one of these equal signs and just see what error I get. Okay, bad input on line 5. So line 5, I know there's a mistake there, and Python hasn't told me directly what it is, but if I do make that mistake, 9 times out of 10, it's either going to be a missing quotation or a missing equals on the double equals. And the program runs. I could develop the program by putting introduction and extending the strings for each of the outputs. But for now, I'm just going to leave it. Okay, let's code together. Okay, the homework points tallies program. Let's have a look. Line number 1. Students equals, and then we have a square bracket. It's on the right hand side of the keyboard near enter. And then we've got some strings. Mason, the first name. Sam is the second name. Careful not to miss off the quotations. Alex is the third name. And Taylor is the fourth name. And let's not finish with a circular bracket, let's finish with a square bracket. Then we have the points that they've accumulated. So let's have a look at the points. And I haven't put the S on the end, so we can go points. We've got 2. Because these are integer values, we don't need to put them in quotations. We only need to put strings in quotations. 2, 1, and remember them, 3, and then 0. Square bracket to finish. Then we've got total points, or total underscore points. We've got 2 words. When we've got 2 words, we can separate them with an underscore in a variable name, and total points is 0. We've just got to initialize this variable and assign it to 0, so it doesn't think we've just invented it when we come to add points to it. Okay, line number 6. For I in range. Now I is our counter variable that's going to iterate through our students list. For I in range for the len or length of students. So students is our list. It's going to go through the length of the list. 2 brackets to close and a colon. Do not forget the colon. Press enter. You'll know you've done it right because it will create an indentation for you. And we're going to print out students square brackets I. Okay, what that does is it means the value within the list, not the value that it's associated with, i.e. Mason is 0. It should print out students I, which is Mason, the string. Comma, earned as a string, and then another comma on either side. We're concatenating these with each other, and then we've got points, and then square bracket I, square bracket, comma, and then points. Finishing off with a round bracket. Next line. Total underscore points equals total underscore points plus points I. Okay, and then I need to go back to the edge because I want to print out the class total right at the end after it's been through the for loop. And I'm going to include another space in there just to separate it up a little bit, because this adds up the class total This is a string, class total, and comma, total underscore points. Okay, let's just quickly explain this code again. So here we have two lists. We've got students, which stores names, and points, which stores their points. Total points starts at 0. The loop uses range, which is the length of the students, to generate indexes 0, 1, 2, and 3. Then students I means the student at index I, and points I means the points at index I. Each loop turn prints one student's points and adds those points to the running total. This is a classic pattern. Loop, access by index, and update total. Pause the video if you haven't quite finished it yet and get this entered into Create with Code. Try and predict what's going to happen and what are the total points going to be when you run the program. Okay, let's have a look. We've got a syntax error, which is quite common when we enter quite a number of lines of code. We've got name point is not defined on line number 7. Let's have a look at line number 7. I've accidentally entered point instead of points. So points is the name of the list, and I entered point instead of points. Typical syntax error, especially when you're live coding. Let's run it again. Okay, so we've got our printout. Mason earned 2 points. So Mason is 2 points. Sam earned 1 point. It should say point, but it says points. Sam and 1. Taylor earned 0 points. And the class total is 6. 2 add 1. Okay, why don't we change the points values here and predict who's got the most. So let's change Mason's to 4. And then I'm not going to say the names because that's giving you the answer. Okay, let's predict what the output's going to be. And then let's try and predict what the total's going to be as well. I'll give you 5 seconds in 4, 3, 2, and 1. And let's run the code. Okay, so Mason's now earned 4 points, and you can see how it links the indexes together. Mason and 4. Sam earned 7 points. Alex, which is spelt incorrectly. Alex, which is spelled incorrectly, earned 3 points. Taylor earned 10 points this time, and the class total is 24 points. Why don't we see what happens if we add an extra name on the end of this list? I want to show you this because we've got a question later coming up about this. So let's put a comma in, and we'll put Dave. Let's see what happens if we get this in there. Ooh. List index out of range on line number 7. So line number 7, what it's doing is it's looking for the points I, but it can't find it because Dave hasn't got any points. So it comes up with an error. Let's give Dave some points, shall we? How many points should we give Dave? Let's give Dave 1 point. Poor old Dave. Let's run it. Okay. Okay, so you can see that Dave has now earned 1 point, or 1 point. Okay, let's code. Okay, let's have a look at the pin entry system, main program. So I have my pin, which equals 1, 2, 3, 4. It's not much of a pin. And I've got attempts, which equal 3 to start with. Entered equals double quotes, because I've got to initialize this. And then on line number 6, I start my iteration. While entered does not equal pin and attempts greater than 0. And make sure you do the colon there. Entered equals input. Enter pin. And the next line, we take attempts equals attempts and take 1 or -1. Down to line number 10, we need to go back to the edge to start our selection statement. If entered equals pin, so it's checking that condition. If that is true, it's going to print out access granted. Else or otherwise, it's going to print out card blocked. Okay, let's run the program and see what happens. Let's enter the pin. Let's see what happens if we enter it incorrectly first. 1, 2, 4, 5. Okay, it prompts me to enter it again. 1, 2, 5, 6. Let's get it right this time. 1, 2, 3, 4. Access granted. So entered equals pin is true. So I get access granted. And the while loop works. And once I enter the pin correctly, that seems to work as well. It'd be great if we could get the attempts to print out as well, but we don't need that because it'll prompt us to do that as well. Okay, so let's have another look. Let's see what happens if I get it correct first time. Access granted. Let's see what happens if I change the pin. 2, 4, 6, 7. And let's change attempts to 1 and see what happens. 2, 3, 4, 5. I'm going to get it wrong, so I get my card blocked straight away. So if I attempt it once, get my card blocked straight away. Let's change this to 3. 2, 3, 4, 5. Card blocked. Attempts is 3. Let's have a look. 1, 2, 3, 4. There we go. 2, 3, 4, 5. And let's enter it correctly to see if we can get it running. Access